Welcome to a new tutorial series from SIG. This time we will focus on the drive monitor within the Flexi Designer. This series of tutorials is structured in 3 chapters. The first chapter is about the configuration of the different encoders. In the second chapter, I'm going to talk about the function blocks in the mock logic. And in the third and last chapter, we are going to create a couple of sample applications. Let's start with the first chapter, encoders, which is divided according to the different encoder groups. First, we will take a look at the configuration of an AB incremental encoder. In the next video, I will explain the sine cos encoder. And last but not least, we will focus on the configuration of the SSI encoders. In this first video about the AB incremental encoders, I'm going to explain where the encoders are located in the FSD, how to connect them to the drive monitor, and how to configure the encoder. In this context, we start straight in the hardware configuration of the Flexi Designer. I have already placed a CPU 0 and a MOX 0 in the configuration area. However, due to our modular concept, we could use any CPU in combination with the drive monitor. Now we are going to place an AB incremental encoder on the terminal of the MOX 0. To reach the encoders, we need to switch in the left sidebar from modules to elements. A simple click on the tab encoder opens the register with the different encoder groups. Overall, 3 encoder groups are available here: sine cos encoder, AB incremental encoder, and SSI encoder. In the register AB incremental encoder, it's possible to choose between 7 different types. Because all are configured in the same manner, we simply take the first one, AB incremental HDL 24V, 2 outputs, and place it via drag and drop on terminal 1 of the MOX 0. Now that the encoder is connected to the MOX 0, we can start with its configuration. By double-clicking on the encoder icon, we reach the configuration menu. In the first tab, Motion Type, we can select the mechanical structure. In this context, it's possible to choose between rotatory motion, linear movement with conversion and rotatory encoder, and linear movement with linear measurement system or distance sensor. This selection has a significant influence on the tab scaling of the measurement system. Therefore, we are going to select the 3 motion types one after another and check the changes. At first, we select rotatory motion and take a look at the tab scaling of the measurement system. With the resolution, we determine the relationship between the information supplied by the encoder and the mechanical moving part. After entering the values in both input fields, the speed acquisition resolution in the unit revolutions per minute is calculated automatically by the FSD. In addition, a wizard is available, which helps to calculate the scaling. This calculation is based on the resolution of the encoder system. It also takes a gearbox factor into consideration. If the output axis and the encoder axis are not the same ones and connected via a gear, the gearbox factor indicates the gear ratio between both axes. By clicking on the button Accept, the scaling of the measurement system is calculated and transferred to the top. And with the button Close, we close the wizard. Now we switch back and select the motion type, linear movement with conversion and rotatory encoder. If we now open the tab Scaling of the measurement system, the units have changed in millimeters and millimeters per second, because we have selected the motion type linear movement. By opening the wizard, we can see that the scaling can be calculated not only in consideration of a gearbox factor, but also with a mechanical factor. The mechanical factor indicates the ratio between the linear movement of the output axis and the encoder axis to which a rotatory encoder is connected. Because there is a conversion between the rotatory encoder and the linear output axis, the output axis is indicated in the unit millimeters and the encoder axis in revolutions. Apart from that, the settings in this tab are the same as in the motion type rotatory motion. Once again, we switch back to the tab Motion Type and select the option Linear Movement with Linear Measurement System or Distance Sensor. Looking at the tab Scaling of the Measurement System, nothing has changed compared to the previously shown motion type except that there is no wizard, because the linear movement is measured with a linear measurement system or distance sensor, and in this kind of measurement system a gearbox factor or a mechanical factor does not exist. Now that we have taken a look at all motion types, we can pass over to the next tab called counting direction. Here we can set the counting direction, which determines if the calculated position difference is considered normal or inverted. Especially for encoders that count in the opposite direction based on the mounting position, this parameter can be used to adjust the counting direction. In the next tab, Speed Step, we find the option to set the maximum speed step that can occur in your application. By enabling the option with monitoring, you can set the unit and the value for the maximum permitted speed step. If larger speed steps are detected by the Mach0, for example by errors like demolition of an electrical connection or a mechanical coupling, the status bits are set invalid in the motion data of the corresponding encoder. Let's go on to the tab Encoder Splitter Box. Here we have to select how the encoder is supplied with voltage, either by the FX3 Mach or by an external supply voltage, for example a PLC or a frequency converter. Furthermore, we can select the required connection box for the encoder, and depending on the type of the connection box, the length of the connection cables. At last, there's the tab Report. This tab shows a summary of the configured parameters. By clicking on the OK button, our encoder configuration is saved and we return to the hardware configuration area. That's it so far for this first tutorial. You learned how to connect an AB incremental encoder to the terminal of the drive monitor and how to configure it. In the next episode we are going to take a detailed look at the configuration of a sine cos encoder.